Take a look at number 8. Can you see the compositeness of number 8? Yeah. So I think oftentimes, like we did before, I'm going to get you started on this, but oftentimes it's a good idea to rewrite. So you guys know what that sine cubed, what does that like really mean?
Sine of 4t cubed.
Yeah, like the whole thing is cubed. Yeah, so we could maybe rewrite it like this. Maybe f of t is equal to parentheses sine of 4t close parentheses cubed. When you do that, doesn't the inside and the outside and all that stuff become a little more clear? Let's make sure we're all straight on that. What do you guys think the most outside box or the big outside function would be?
Sine.
Not sine, it would be cubed, right? Like something cubed is the most outside function. And then what's you can see there's like two others, right? What is the middle function, like the middle box?
Sine.
And then the little tiny box? 4t, right? So let's see if we can unpackage this with the chain rule and find f prime. Ready, set, go. F prime, and so we need to start with the outside box, right? So Doug, if I open up that outside box, in other words, like differentiating the outside function, what does that look like first? What's the first piece of the chain?
3 sine 4t squared.
3 times sine of 4t squared. That's exactly right? That's the first link in the chain. He's differentiated the outside, but he's left all the inside stuff intact, right? And now we need to multiply by the next link in the chain, right? Delaney, do you have that one?
Cosine 4t.
Yep, times cosine of 4t. Awesome. Very good. And then we got one more little box to open. When we open that little box, we end up going times 4. So times 4 will give us the last link in the chain, and we're done. What do you guys think? Did that go well for you? You seem pretty confident. Yeah? Okay, fantastic. All right, well, let's do our last one then, number 9. Number 9 says, find the equation of the tangent line of f of x equals 9 minus x squared to the 2/3 at the point 1, 4. I hope this is becoming like a more familiar question. We've done this maybe in class, I want to say like 3 or 4 times. I think we did it on our quiz at least twice. Finding the equation of the tangent line. What are the two things that we got to have to put together to get this? Point and a slope, and specifically the point of tangency and the slope of the tangent line. So what's the thing that I just basically gave you without any effort on your part? Point of tangency, right? 1, 4 is the point of tangency. So your big effort here is going to be to try to find the slope of the tangent line. So let's try that. See if you can find the slope of the tangent line, put it together with the point of tangency, and we'll have the equation of the tangent line. It's really a derivative, right? Specifically dy dx, or if we're going to just use this notation we have right here, it's going to be f prime. So I'm going to find f prime here. Ashley, what did that look like for you when you tried to find f prime?
I got 2/3 parentheses 9 minus x squared to the negative 1/3, and then times negative 2x.
Okay, so guys, Ashley has nicely outlined what needs to happen here as far as our f prime. I want to be really clear, or as clear as I possibly can be about this. Can you guys explain what that is? It is the derivative, but in terms of the thing that we're trying to find.
It's the equation of the slope at any
Yeah, it's the slope at any point, right? Yeah. So, we could plug in any x value that applies to this function, and it would give you the slope of the graph at that point. We don't care about any point, though. Which point do we care about? 1, 4. So x equals 1. So how do we then take this and turn it into the slope at 1? Plug in a 1. Okay, so let's do that real quick. F prime of 1 is equal to 2/3 times 9 minus 1 squared, of course, is just 1, times negative 2 times 1 is just negative 2. You can actually do all of this without a calculator, right? So 9 minus 1 is 8. Think about it. 9 minus 1 is 8. What is 8 to the negative 1/3? Well, 8 to the 1/3 is 2. So 8 to the negative 1/3 is 1/2, right? So you could say f prime of 1 is 2/3 times 1/2 times negative 2. So I guess the negative 2/3, right? The 2's would cancel. Morning. So I'm getting negative 2/3. Still doing okay? Okay, so then our final step here would be then to take the point of tangency, which is 1, 4, and the slope of the tangent line, which we just figured out, put it together in some kind of a linear equation. Could be point slope, could be slope intercept. Your choice there. McKenna, how'd you finish this?
I just used point slope form, so
Okay.
I got y minus 4 equals negative 2/3 parentheses x minus 1.
Nice. All right. Can I show you guys a little trick with a calculator? Go ahead and get your calculators out, and I'll show this to you. There we go. Okay, so I want you guys, what we're going to do is we are going to use the calculator to find the slope of the tangent line. The calculator will do a lot of the heavy lifting for you. So what we're about to do, if the calculator is active, you would be foolish to not do this, right? If the calculator is not active, you got to do it by hand, just like we just did a second ago. There you go. So here's what we do first. I want you guys to take that f of x equals 9 minus x squared to the 2/3 or whatever, and I want you guys to put that into your y equals menu, kind of like that. So this is left over from when we did it the other day in the other class. So I want you to put y1 equals 9 minus x squared in parentheses to the 2/3. What you're doing is you're inputting f of x. You're not inputting f prime or something else like that. You're specifically putting f of x into your y1 equals menu. So go ahead and take a second and do that. Now let's remember what we're trying to find. We're trying to find f prime of x. F prime of x. Okay, so you guys all have that in there? So y1 equals, you put in f of x. Let's go ahead and quit out of that screen. And here's what we're going to do. We're going to use what I think for most of you, if not all of you, is a totally new feature. I want you guys to push the math button. Math is over there under the alpha button. So math. And we're going to use, like I said, I think it's brand new for you guys. Notice that option 8 is called n-deriv. Stands for numerical derivative. And so let's go ahead and select 8. And when you select option 8, it's kind of a cool thing. Look what shows up. dd something of something at something equals something. We can fill in a lot of the blanks, right? So in other words, let me explain what your calculator will do for you. Your calculator will take whatever you put in for y1, it will differentiate it, and then plug in whatever value you want it to plug in. So this works for numerical derivatives really well. And so a problem like what we just did, this would be a very handy thing. In fact, I'll say it again. If the calculator's active and you didn't do this, you're wasting your time. Okay? I'll talk about what you need to write down. It's pretty minimal. You do need to write some specific things down to indicate what you did, but this is much, much easier than doing it by hand, much faster. So here we go. We're going to do ddx, right? Because our function was in terms of x. So go ahead and push the little xt theta n button for your input variable. So I'm going to do ddx. That means do the derivative with respect to x of whatever comes next. It's a little operator. And so I had you guys put your function into y1 for a reason. I wanted to kind of maybe show you something else. Maybe you've done this before. There's a button maybe you haven't pushed. It's the vars button, V-A-R-S. It stands for variables. So go ahead and push the vars button. When you push that, I want you to use the arrow pad to slide to the right where it says yvars. So vars, yvars. Go ahead and select function. And when you select function, look what shows up. y1, y2, y3, y4, dot, 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 dot. Now, where did we put our function? So go ahead and select y1, and look what shows up. ddx of whatever y1 is. Now, if your y1 is blank, you're not going to know what to do the derivative of, right? But we put our function into y1, so you're telling it, do the derivative of whatever I have in y1, and then the final thing we want to do is we want to give it the point of tangency, right? When x equals, in our case, 1. So go ahead and hit 1, and once you've done that, the only thing left to hit is enter. Hit enter, and look what it does. It gives you negative 0.666666, blah, blah, blah. So this is negative 2/3, isn't it? It's accurate out there to the third decimal place. And so that did all of the work for you, didn't it? Let me finish this up really quick. I'm going to write this. Let me write this on the other little screen here. So, oops, I want to do this. Let me show you what you'd need to write down. Is that okay? And then I'll get your guys' questions. So in a situation like that, if the calculator's active, I know it. I know the calculator's active, and I'm really hoping that you'll do what we just did. Make sense? So here's what you have to write down. You must write this down. There's no alternative to this, really. You have to write down f prime of 1 equals negative 0.667, something like that. You must specifically write that down, and I'll point out the different things here. This right here, you might say, wow, why is it so important that I write down f prime of 1? That tells me what you did, right? It tells me what you intended to do. It tells me that I did the derivative of f, and then after I did the derivative of f, I plugged in a 1. Now, what's the real truth? Didn't the calculator do that for you? But who told the calculator to do that? You. So that means you know what you're doing. You just have the calculator help you out with the little details. That makes sense? That's why you have to write down f prime of 1. If you just have nothing, you just have negative 0.667, I don't know where you got that. There's 2/3 floating around all over the place. It's amazing how many times people will get a right answer for a terribly wrong reason. So I want to see that you did, okay, I really did f prime of 1, and the calculator told me that it's that number right there. That makes sense? If you write that down, that's all you got to do. So this problem right here, if the calculator were active, here's what you do. You write down f prime of 1 equals negative 0.667, and then you just write y minus 4 equals negative 0.667 times x minus 1, and you're done. So you see how the calculator is a pretty significant aid here, right? It's a big help, and it should make your life quite a bit easier when the calculator is active. Okay, so your questions. Okay, Titus, go ahead.
My calculator, it doesn't do the thing. It just says in deriv and then like a parenthesis.
You got the old syntax. I can show you how to do that in a little bit. Yeah, it's not that hard. You got to use the comma and a few other things. You have an 84?
Yeah.
You can actually download the new operating system from ti.com,
Okay.
and it'll look just like that.
I think I figured it out though. If you graph it, or if you graph it.
Yeah, the graph is not as good.
Like dy dx.
It's not as good.
It's not.
Yeah, it's accurate to fewer decimals. Do you want to be as accurate as you can to as many decimals? You just go function, comma, x, comma, the number you want to plug in. That's really all it is. It's not that bad. Yeah. McKenna? Same thing. If you guys want to sit down with me, happy to show you how to do that. Or maybe more importantly, show you how to download the new operating system from TI, and makes it even easier. You just do that. Okay. Any other questions? Is that happy? That's happy, right? Okay, good. I think it is. So please, don't forget that is there. We'll use it in part by yourselves, okay? So the instructions, if you look back up, aren't the instructions to find dy dx?
Yes.
Find dy dx. And so let's try that. Take a look at number 2 here, and I want to let you know there's a kind of a trap, a scary thing that if you're not paying attention is going to get you really badly. It's going to really mess you up. The first term, x squared times y. If I'm going to do find dy dx, I got to differentiate with respect to x, but what rule do I have to use?
The product.
Why do I have to use the product rule in the first term? Yeah, I got two different functions being multiplied together. I have a product of functions. So I have to use the product rule. So if at any point here you have a question about what's going on, please say something. So here we go. Here's what it would look like. We'd do ddx of everything. So ddx of the whole function. So it would look something like this. And all I'm going to do here at the start is I'm just going to do ddx of the first term. I'm going to have you guys do the second term in a minute. So as you guys know, the product rule is 1d2 plus 2d1. 1d2 plus 2d1. So here we go. Here is 1. Make sense? Okay, so there's just 1 times d2. So 1d2. Here's what d2 would technically look like. Times 1 dy dx. Now the 1, does that really need to be there? Of course not, because times 1 is not going to change anything. So that'd probably be the only time you actually see me write that. But here's why it's there. What's the derivative of y to the first? It's 1, right? And notice I didn't say ddx, I just said the derivative, right? So the derivative of x is 1, right? The derivative of y is 1. The derivative of t is 1. But then you've got to ask yourself, all right, well, what is my variable that I'm differentiating with respect to? So if I'm doing ddx of a y, isn't the chain rule going to show up? So it would be 1 times the derivative of the inside. So 1 times dy dx. And keep going. We'll compare this a little bit. So there's 1d2 plus 2, right? d1 would just be 2x. So I want to ask you a question. See if you can discern this. I just did 1d2 plus 2d1. Why does my first term have a dy dx, but my second term does not? Jonathan.
Because the y isn't being differentiated at all.
In the... You're half right.
Like, I'm not sure.
Okay, you're half right. You got us halfway there. Here, what do you take us the rest of the way there? He said the y is not being differentiated, and he should have finished that in a certain way.
Second part.
In the second term. Yeah, there you go. Seriously though, think about it. In this first part, wasn't the y being differentiated? We did 1d2, and isn't the 2 a y term? Or a y factor, I should say. But then when we did this part, we did 2d1. We were doing d, right? We were doing a derivative, but we were doing the derivative with respect to x of an x factor instead of a y factor. And that's why the dy dx shows up in the first one, but not the second term. Okay, so let's see if you can take that idea and apply it to term number 2. Ready, go. ddx of the second term. So give it a shot.
Y squared times 1 plus x times 2y.
Anything else you want to throw in there? You're really close.
Equals 0.
We'll get there in a second, but there's one more little thing. It's actually an important thing, but it's one more thing. Let me take you through what you did, because you did a really good job. So this right here is 1d2, right? So y squared times ddx of x is just y squared times 1. That's a great job. This is where we want to throw one more thing in there. So this is 2d1, right? So 2 is x, no issues there. Remember, we're doing ddx. So when we do ddx of y squared, I totally agree with you that it's 2y. But then remember, the chain rule is always present, right? And so when we multiply by the chain rule, what was the inside function for d1?
Y.
Y. And so if we multiply by the ddx of the inside, it wouldn't just be a 1. It'd be dy dx. There you go. Yeah, so dy dx, and of course what you said there at the end, equals 0, is totally correct as well. Okay, so what do you guys think? Did you see what I was getting at there? Do you guys, some of you had that maybe? Yeah? Okay. So Delaney, does that make sense? Because you had everything right. It was just that dy dx. And the dy dx is pretty important, right? Because that's what we're trying to find. So to not have that there, it's going to pretty much change your answer significantly. But does that help? Is that good? Okay, awesome. Thank you. Okay, so it's sort of complicated looking. Here's what we need to do. We need to get the dy dx all by itself. And so I would propose to you this. We have two terms with dy dx. So let's leave all of the dy dx terms on the left, and anything that is not a dy dx term, let's take it to the right side. Fair enough? Okay, so here's what that would look like. If I did that, it would be, let's see here, it'd be x squared times dy dx plus 2xy dy dx equals negative 2xy minus y squared. Just a little bit of algebra. Does that make sense? I left all the dy dx terms on one side, took the non-dy dx terms the other. So here are the non-dy dx terms, right here and right here. And then the other two terms actually have a dy dx, so I left those. So these went, and the other ones stayed. Still hanging in? Okay. So the goal is to get the dy dx by itself, and I've obviously got two of them on the left. So how do I start the process of isolating the dy dx? Factor it out. That's right. So I'll come up here. So we end up with dy dx, and then the leftovers would be x squared plus 2xy equals negative 2xy minus y squared. Oops. Oh, that's nice. I guess if you hit that button, everything gets erased. But I made it come back. There we go. Okay, so then what's our final step? Division, yep. So dy dx is equal to negative 2xy minus y squared over x squared plus 2xy. Can I give you one brief word of caution on this? let's pretend that this is a multiple choice, right? You're going to select your answers from the options, hopefully select the right one. You could conceivably see an answer that looks like this within your options. See what you think about this. Is that the same thing as what we got?
Yes.
It is. Notice how every single sign is changed, right? So what did I multiply the top by? What did I multiply the bottom by? So I multiplied the top and the bottom by the same thing. What did I really multiply by? Just a smart 1, right? And so I just want to give you a word of caution. Sometimes, didn't we choose to leave the dy dx terms on the left and move the other ones to the right? What if we decided to do the other way? Because there was no right or wrong way to do that. What if I took the dy dx's over to the right and left the non-dy dx's on the left? Wouldn't every single sign be switched? Still the right answer. So please be aware of that. Like, you might be doing everything right, and you look at the answer options, you're like, whoa, it's not up there. But it really is, right? Just the other form with the negatives, everything changed over to the other side. Okay, we're going to do one more here, and then we'll be good for the day. And here, I underlined it for you. What does normal mean when it comes to science and math? McKenna.
I have a question on the last one.
Oh, okay. What's your question on the last one?
Could you cancel out the 2xy and make it 2xy?
No. Sorry, I mentioned that in the other class. I'll come sit by and we'll talk about that in a second. So let's talk about normal. What does normal mean in math and science? Perpendicular, okay? So normal means perpendicular to the tangent line. That's what normal means, perpendicular to the tangent line. And so the tangent line, if we use Leibniz's notation, the tangent line would be dy dx. The slope of the tangent line would be dy dx. So what is the normal line slope?
Negative dx dy.
Negative dx dy, right? So that would be the opposite reciprocal. Remember that concept from Algebra 1? Perpendicular line slopes are opposite reciprocal. So we're kind of going back to that. So there would be two ways to do this, and I think I only have time to show you one way, or we'll kind of work through this together. But let's at least do this one way. I've got x squared plus y squared equals 25. Here's what I would propose. Let's go ahead and find dy dx. And then we'll manipulate it to get to the normal line slope. So x squared plus y squared equals 25 is our equation. And by the way, what is that thing if we graphed it? It's a circle, yeah. Circle centered where? Origin, radius, 5. Yeah. That's just a regular old circle. We're finding the slope at the point of tangency, which is 4, negative 3. So we're going to try to find dy dx on this one. Give you guys. So if we're trying to find dy dx, Chloe, what do I have to do to this equation?
You need to times it by dx.
I got to do ddx, right? Yeah, so it's not really multiplication as much as it is ddx is saying do the derivative of this thing. So Chloe, what is ddx of x squared? 2x. And then Chloe, how about ddx of y squared?
2y times dy dx.
So far she's doing a great job. Equals. So far so good? So we do a little bit of algebra. This is much easier, obviously, than the previous one. Get the dy dx by itself. So I get dy dx is equal to negative x over y. So what that is the slope of the tangent line. So I'll write that over here. Slope of the tangent line. And I could go ahead and specifically find the slope of the tangent line at my point of tangency, couldn't I? So what's my point of tangency? So Mandy, if I'm going to do the slope of the tangent line at 4, negative 3, what do I get?
4/3.
So we get, let's see here, it would be negative 4 over negative 3, which is 4/3. Totally agree with you. But of course, that's not what we want in the end, right? We want to know the slope of the normal line, which is perpendicular to this one. So here's my notation. I'm going to write negative dx dy, like you guys mentioned earlier. So what I'm going to do is I'm going to do the opposite reciprocal. So Pristine, what would that look like for this one? If 4/3 is the slope of the tangent line, what would be the slope of the normal line? Negative 3/4. Good. And that's what I want to use, is that slope of negative 3/4. So then my final step would be to use my point of tangency. So y minus negative 3 equals slope of the normal line parentheses x minus 4. Of course, that's in point slope form. You could use the other form if you want. So here you go. All right, we are only one behind now. We're rapidly catching up. Was this on video? Did anybody notice? If this was on video, you might actually be able to see the other method that I showed the other class, because we did 2 methods in there. But if you want, if you care to, that's totally fine. So have a wonderful day. I will see you guys tomorrow.